So now we're going to look at slicing a list. So let's just go get a list. We'll get a nice ordered list rather than an unordered one. We'll get a list of strings just for something to work on, like this. And also, I'm actually going to copy out like a general pattern, but let's just run this actually. So we've got our list of names: Alice, Bob, Charlie, Darren, Elsa, and Fiona, and we're going to attempt to do some slicing. So what is slicing? Slicing is kind of like, if you can imagine, a list is made up of a certain number of names, and we want to sort of like extract like the middle part of it, or just extract the first part, or maybe just extract the last element. And we saw some functions that, or methods that we could use on lists already, and we could achieve some of those but not all of those. So slicing gives us some extra capability. The first thing I'm going to do is just copy a general pattern and paste it into here, because this is kind of like what slicing might look like. If we have a list, we call it our list. We'll start at some position, and remember that indexing starts at 0 and will end at some position. So our last position here, whatever the index number is, and remember we can use negative indexing as well, so we could end at -1. And there's also a step value. The default step value is 1, so just go through each item, but we could hop over and skip items if we wanted to by using a higher valued step. So from that we will attempt to do some lists. So let's do some lists like this. And one thing to note is that, I guess just before we do lists, is that the first item is inclusive and the second item here is exclusive. So for example, but it'll become more obvious when we do it in a practical sense. If we set this to 0, the first item would be included. If we set this to the value of, say for example, 2, it's actually exclusive. So we'd need to, so this is 0, this is 1, and this is 2. This one would actually be excluded. If we just set 2, then we'd only get these 2 items, and we wouldn't get index number 3. So and we'll see this, see how this manifests itself. So let's slice a list. We'll just try it out, and we will create a new variable. And the other thing is that slicing actually will create a new list. So whereas when we did our other methods, quite often we were doing the list was being operated on in place, as opposed to being copied and creating a new item, apart from with the copy method, for example. Here, when we do slicing, we're always effectively creating new copies of the list, which is memory inefficient in a way. So there's certain use cases for that and other cases where you might want to operate in place. So let's just set a variable and say like names, and we just want to get, say for example, names A to C. So A to C, and we can set that equal to names. This is our names list. And our first name is, or our starting position is 0, which is Alice, index 0, and then our Charlie will be index number 0, 1, and 2. So if we were to put 2 in here like this, and if we were to actually print it out, so we could sort of like print our names of A to C, we'll see what happens here. So names A to C. So if we were to try to do that, notice that we now get Alice and Bob, and we wanted to get Charlie as well, and that meant that we had to do index number 3 because of this exclusivity. So we always need to go one number higher than we need to get if we want to have that included. And the reason that that's the case is because the index always starts at 0, so you're kind of like always shifted 1 across or 1 down, actually, if that makes sense. So that's how we slice a list in general. We just have a start and a stop. We could also do the same like this, which is we could omit this 0, and that will just go up to the index number 3, and we would achieve the same result. So we don't actually or have to put in the 0 value. So that's that. Now let's do something else. We'll try to get the middle portion of it, or somewhere else. So let's recreate this. Actually, we'll copy this, and this time we will go for names. We've got A to C, so let's do D, and then we'll go to F, just like this. And we will therefore start at index number 3 and go up to index, say for example, number 6. Now, why index number 6? This is index number 0, this is index number 1, number 2, number 3. This time it's inclusive because it's the first part of it, which is inclusive, so 3 gets included. And this is number 0, 1, 2, 3, 4, 5. But if we did 5, it would be exclusive and Fiona would be missed, so we'd have to do 6 to go above it in order for that to be included. And then this would be names D to F. That's what we'd get, and let's just do it. D to F over here, and when we run that, we do indeed get Darren, Elsa, and Fiona, which is the names D to F. So we're able to extract the first part of a list. We are able to extract the second part of a list. We could do this in a couple of different ways. And again, if we wanted to just go from D till the end, so something like D to the end, assuming that, for example, we had more names in our list, we could then do, so D to the end here like this, D to end. We could omit this last value, and that means that the list will just keep going on until the last item. So omitting a value just means go till the end effectively. And if we had an extra item in our list, so Fiona, and then say for example Gary, so EFG, when we run our code now, notice that we get Darren, Elsa, and Fiona, which is D to F. So that's all encapsulated with this 3 to 6 over here. That was our middle slice. This is index number 3. This is index number 4, and this is index number 5. Index number 6 is excluded. So that was how this is generated. And then finally, we should say D to end over here. When we run it, this just runs through till the end, and then we get all of them, including Gary. So that is the first part of it. Now we can also look at the we can reverse a list, and we've seen reversing a list because we got the reverse method on a list. So we could do names dot reverse, and we could even reverse it alphabetically, or so we could reverse our list like that. But what we're going to do is we're going to reverse a list in a different way. So reverse a list, this time using index slicing, and it's going to create a new list. Now our reverse method didn't create a new list. Our reverse method operated on the original list. So that's basically the key difference between the reverse method and slicing to do a reverse. Now let's just create a reverse. We'll create a variable called reverse names, reverse underscore names, and then we will set that equal to names, and we're going to use some slicing. Now we're going to slice from the beginning, so we don't need to put in index 0, we can just leave it from the beginning and to the end. And we're going to this time invoke a step size, but instead of doing a step size increment of 1, we are going to stick in -1, which means that we are going to step backwards in the list. So let's try and print out our reverse list. So print our, we'll call it reverse list. So something like this, and let's print out reverse names, because that's our reverse names over here. And let's run it, and we see that our names now, this is the forward version of the names, and this is our reverse list over here. So we're going backwards. So, and we've created this new list, so a copy of a new list. So, and we can observe that these slices are copies. And the way that we can observe this is by doing the ID. So we could say the sliced list. We should say the sliced lists are in fact new lists, i.e. they are copies. They're copies of parts of lists is what they are, and we can actually print out the ID just to check this, because remember that the ID gives us this unique, this identity of an object, and if it's in the same memory space it will have the same ID, and if it's a copy somewhere else in the memory it will have a different ID, so it'll have a unique ID. So we'll do the ID of names because that was our original list, and then let's just take the ID of any of these other ones. So we take the last one, for example, which is the reversed names. So let's just do reversed names, and we will observe the IDs of them over here, and we see that they are two completely different numbers. This one ends in 416 and this one ends in 640. So they're different IDs. They exist in different parts of the memory. And that is an introduction to slicing in lists, or list slicing.